To begin, I wanted to show you a demo that shows all the code within context that I showed you in the slides. So as I run the code here, you can see that it draws the triangle on the screen just like we had in the slides. So to begin, the first thing that I'll do is get reference to the canvas. So I'm calling getElementById, looking for the canvas element that just has an ID of canvas right now. And then I need to make sure that the browser supports canvas. So I'm doing feature detection against getContext. And as long as all that returns back as true, then off of canvas, I can call getContext asking for the 2D context. Now, also, like I said in the slides, there's a 3D context available as well. I don't get into that in this course. Everything that I'm showing you right now just works with the 2D context. So once reference to the context is available, I can call beginPath and then call moveTo, line2 a couple times, and then finally fill the triangle. Remember that calling fill will take the last point and connect it to the first point, and then fill it in with the color that's been set. In this case, it's just the default color, which is black. So that's a real basic shape. Let's take a look at a different type of shape. So this is a Tetris shape. So let's say you're building your first game and you want to create a shape that looks something like this. So like I showed you in the basic shape example, this is how you can do feature detection for Canvas. But something that's perhaps a little bit easier to use is to use Modernizer, as I was discussing earlier in the course. So here I'm accessing Modernizer, requesting to see if Canvas is supported. Then I can call getContext in order to get the current context off the canvas. Then call beginPath in order to prepare the context for the commands that are coming its way. Then find the point of origin by moving to position 100, 100 within the canvas. Now these calls to line2 create points along the path, but it's just creating the path at this point. It's not stroking it. It's not filling it. It's just adding the instructions to the line that's being traced in the canvas. So after adding in each one of the stop points in order to trace the contour of the shape, I call closePath. Now to fill the shape, I pass in this hex value for the blue color and add that into fill style, and then I can call fill. Now in order to give it its outline, then I switch over to line width, giving that 6 pixels of line width, and set the value for line join. Line join is the area where the lines come together. It can be round, it can be pointed. There's a number of different options you have available to you. Then I'm setting the stroke style, here using another hex value for the color, and then calling stroke. So as all of these commands are executed together, it creates the shape that you see over here in the results window. Now, one of the things I want to make sure you're aware of is that the order of operations does have an effect of how drawings end up on the canvas. As this diagram depicts, if you apply the fill first and then stroke the shape, the stroke will be distributed on the boundary line and will go on the outside and the inside of the shape. But if you apply the stroke first and then fill, the fill color will fill the shape all the way up to the boundary line. So make sure that as you're drawing shapes, if you need them to be identical, that the order of operations in which you're stroking and filling your shapes is done in the same way so that you get the same results. Next, let's take a look at some rectangles. Now, they're being formatted as squares, but the API call is for rectangles, so that's why I've labeled it this way. So there's a number of different things happening within this example. First, there's a square that's created that's given a full fill. Then there's another square that's given a fill, but it's using an alpha transparency. Next, another square is used, and all the data is cleared out of the canvas, so it basically pokes a hole through everything else that's been set up on the canvas. So it looks like there's a hole in these boxes here. And finally, I trace the same shape as the square that's been cleared and stroke that, so it looks like an outline is being done to the cleared out area. So now let's take a look at the API calls required in order to make this happen. Everything from here on up is basically stock code that you'll see in just about any one of the examples. I always need to get reference to the canvas and then get instance of the context. Once I have the context, then I can start working with it. To begin, I'll set the fill style. And what's interesting here is last time I showed you the fill style and the stroke style of how it accepted hex values. Here you can pass in RGB values as well. It's interchangeable as long as you set it up with the right format. Hex values are prepended with the hash sign or the number sign, and RGB values are formatted this way. From here, instead of drawing a specific shape, I can fill a rectangle. Now my rectangle happens to be a square because the width and the height are equal, but FillRect gives you the flexibility to draw any type of rectangle that you want. As the comments indicate, you first pass in the X coordinate and the Y coordinate of where you want the rectangle to show up, and then pass in the height and width. So after this code executes, the rectangle is rendered onto the canvas. Next, I create another box. This time the fill style uses RGBA, which uses an alpha transparency. So here, by setting this value, I'm making it 50% transparent. To position the box where I want it on the canvas, I'm setting the X and Y coordinates to 80, 80, and then width and height equal to 100, so I have the same size box as I did before. Now, in order to punch out the area in the middle of the boxes, I can call clearRect. Again, the arguments list is the same, passing in the X and Y coordinates and the width and the height of the shape that you want to clear. And now I just use those same values down here for StrokeRect in order to stroke the outline of a rectangle, making it look like that punched out square has an outline around it. Once again, I'm using an RGB value in order to give it the color that I want and setting the line width equal to 6. And so all this code running together produces this result.